So I want to look at elementary probability, okay? And then we can see how we can apply that. So please, I'll try to be as systematic as possible. Then what will need much more focus, I will definitely do that. Especially, it will be much easier. Those that are sending consents, you can either send to my inbox on WhatsApp, or you can send to someone, let's say maybe Taonga, and then she can forward those consents to me, okay? In case there's something that I need to focus much more on, especially at the end of these lessons, I can still do that at some other point, okay? So let me share my screen so that we look at the other one. Okay, so let's look at elementary probability theory, okay? I'm still using Professor Siziya's notes, like I mentioned earlier. So now those are the objectives. We want to define probability in terms of long run, and also explain the addition and multiplication laws. I'm sure this is quite, we are quite familiar with this. It's quite a simple and short topic, okay? So let's try to define probability. So a probability gives, okay, it gives more like the likelihood that a defined event will occur and is qualified as a positive number, okay, between 0 and 1. So its probability is always between 0 and 1, okay? You can't have something less than 0, and you can't have something greater than 1, okay? Then if probability is equal to 0, if P is equal to 0, then it means that there's no likelihood. In other words, it's impossible for that particular event to occur, okay? But if probability is equal to 1, then it is definite. A particular event is definitely going to occur. For example, if we say the probability that what example can I give? The probability that you are going to write exams, okay? Or rather, there are going to be exams at the School of Medicine, okay? At some point, maybe let's say in this particular year, it's almost definite that you're going to have at least one exam in this particular year, okay? Then it means that probability is equal to 1, okay? But if we say probability that there's going to be no exam at all, then it means that probability is going to be 0, okay? So when something is definitely going to occur, probability is equal to 1. When something is definitely not going to occur, then the probability is equal to 0, okay? Now, so this is the proportion of times an event is occurs in the long run, okay? So the proportion of times, what is the likelihood that something is going to occur? Now, this is what I was explaining, that if an event cannot occur, then P is equal to 0. So it is an impossibility, okay? Then if an event is certain to occur, is definitely going to occur, then probability is equal to 1. Then, like I mentioned, probability is measured between 0 and 1. Okay, now, let's try to discuss what is called the addition theory, okay? So the addition theory, it is also called the addition rule or the sum rule, okay? Addition rule or sum rule. So this addition rule or sum rule states that the probability that, let's say for example, we have two events. Let's say we have A and B. Let's say those are the events, huh? Okay. So the probability that event A or event B will occur is the sum, okay, of individual probabilities that A will occur, okay, or rather will happen, and that B will happen, okay? So it is the sum of individual probabilities. So A occurs independently and B occurs, all right? So the sum of the probabilities of these two is what is going to give us, is what is being referred to as the addition law of probability, okay? So it says that the probability that A or B will occur is the sum of the individual probabilities that A will occur and that B will occur as well, okay? Now, this can, when I don't know if you remember from mathematics, okay? You look at the union of a set, okay? So you'd say that we say that the probability that A or B will occur is equal to the probability of A plus the probability of B, okay? Probability of A added to probability of B. I wish I was using a board. Anyway, I hope you are still following. Now, so events that cannot occur together are said to be mutually exclusive, okay? So if they cannot occur together, if they are occurring independent of each other, then they are said to be mutually exclusive, okay? So an example of such is when you're tossing a dice and also throwing, when you're tossing a coin and throwing a die, okay? So those are occurring, they're not happening together, they're not occurring together. So they are said to be exclusively, they are said to be mutually exclusive, okay? Now, let's consider this case. So consider tossing a fair coin and throwing a die, okay? So probability, remember a coin only has two sides. So it can either be on the head or on the tail, okay? So meaning that the probability that you're going to have a head is going to be 1/2 because there are only two sides. Then when you look at a die, it has 6 faces, okay? Isn't it so? It has 6 faces. So meaning that the probability that you're going to have a 1 is going to be 1/6. The probability of you having a 4, for example, is going to be, let's say, 1/6, okay? So this means that the probability of getting the head or a 4, okay? Head or a 4 is going to be the probability of getting the head plus the probability of getting the head. So if you add these two, you're going to get 0.667, okay? Or 1/2, 1 divided by 2 plus 1 divided by 6, which is going to give us what? You're going to get something like what? 1/2 plus 1/6. That is going to be, is it 5? Okay, something like 5/6, okay? If I'm not mistaken. So that is going to be the probability. So in other words, what we should understand is that when we are looking at, if we say it's like either of them, the probability of us having either the head or the tail, then we have to add. Okay, so in general, I think I already explained this. In general, for events, let's say E1 and E2, in my explanation earlier on, I gave an example of events A and B, okay? So if we have, let's say, event E1 and E2, then the probability of us having event E1 or event E2 is equal to the probability of event E1 plus the probability of event E2, okay, or rather E2, provided E1 and E2 cannot occur together. So events that cannot occur together are said to be mutually exclusive. So these are not occurring together, so they are mutually exclusive. Now, this is just another example. Let's look at this this particular example. So if, let's say, for example, event, the probability of the first event is 0.4, and the probability of the second event is 0.8. Okay. Now, if we want to look at, if we want to apply the addition law or rather theory on this particular events, then we find that these cannot mutually be exclusive. They cannot occur. They cannot be mutually what? Exclusive. Why is it so? Because when you add their probabilities, or rather when you apply the addition law on these two events, what you're finding is that it's going to give you something that is greater than 1. And remember, we said that probability is always between 0 and 1. Okay, so probability of E1 or E2 is going to be equal to probability of E1 plus probability of E2, which is going to be 0.4 plus 0.8, which is going to give us what? 1.2. Now, this is greater than 1. Okay, if it's greater than 1, it means that it is impossible in probability. Okay. All right. So let's look at the multiplication law, or rather multiplication rule. Okay. Now, what does it mean? What does it state? So multiplication rule states that when probability states that the probability of A and B both occur is equal to the probability that B occurs, okay, times the conditional probability that A occurs, okay, given that B occurs. So now what we're trying to say is that you have two events, all right? You have two events. Now, this multiplication law states that the probability that A and B both occur like at the same time, okay, is going to be equal to the probability that maybe let's say the first event occurs multiplied by the conditional probability that the second event occurs, provided that the first event occurred. So both of them are supposed to occur. If you have to go to the second event, it means that it's like you're assuming or you're considering the fact that the first event has already occurred. Let me give a simple example. Most of the times you find that someone is going to have lunch and then they'll have supper, right? So most of the times you're going to assume that when someone has their supper, you assume that they already had their lunch, isn't it? Or maybe if you're considering lunch and breakfast, you would say that the fact that they're having lunch, probably they also had breakfast. Okay, so there's more like a conditional event. There's a conditional event there. For you to look at the second event, you are assuming, or rather, it's provided that the first event has already occurred. Okay, so I'm trying to say that multiplication rule states that the probability that A and B both occur is equal to the probability that B occurs times the conditional probability that A occurs, given that B already occurred. Okay, or you can start with A. Okay, you can say it is equal to the probability of A multiplied by the probability of B in simple terms. So you just multiply the individual probabilities, the probability of A and the probability of B. That is going to give you what is called the multiplication rule or law of probability. Okay, so let's look at this. It's the table is not on this PowerPoint. It's not in order, but we should see that the sides of the die. Okay, we have 1, 2, 3, 4, 5, and 6. Okay, so this 5 and 6 are supposed to come somewhere there. Okay, then the coin has two sides. Remember, there is the head and the tail. Okay, so we have it can happen that when you toss the coin, okay, and throw the die, it can happen that you have the head and the side of the die where there's a 1. Okay, or you can also have the head and the 2 on the die. You can have the head and the 3 on the die. You can have the head on the coin and a 4 on the die, or you can have a head and a 5, a head and a 6. You are looking at both the coin and the die, okay? Or you can also have the tail and 1 on the die, a tail and a 2, a tail and a 3, a tail and a 4, a tail and a 5, a tail and a 6. Okay, now what is the probability that you are going to have a head and a 4? Okay, so the probability that you're going to have a head and a 4 is going to be equal to, remember, this only happens once. You can only have this can only happen at one point at once. Okay, that is, you having a head and a 4 at a go can only happen once out of the 12 events that are likely to occur. So meaning that the probability that you're going to have a head and a 4 is going to be 1 out of all the 12 events, which is 1 over 12. Okay, so that is going to be the probability of you having a head and a 4. Now, let's try to go back to this multiplication law. Okay, remember I said that it is equal to the probability of the first event multiplied by the probability of the second event. So in this case, the first event is you having the tail. The head. What is the probability of having a head? The probability of having a head is 1 over 2, because the coin only has 2 sides, right? Then the probability of having a 4 is 1 over 6, because the dice has how many sides? Has 6 sides. So if you multiply those 2 events, the probabilities of those 2 events, which is 1 over 2 multiplied by 1 over 6, it is going to give you 1 over 12, which is basically what we've gotten from that particular table. Okay, so let's try to go through that. So H and 4, which is head and a 4 occurs once. So this event occurs once out of the 12 possible outcomes, given the probability of 1 over 12. All right. So the outcomes of getting the head from tossing a coin and a 4 from throwing a die do not affect each other. So they are said to be independent. So they are not affecting each other in any way. Okay. When you toss a die, when you toss a coin, it's not going to affect you throwing a die in any way. So they are said to be independent of each other. Okay, so that is what we are saying. In general, if 2 events E1 and E2 are independent, then the probability of E1 and E2 occurring is equal to the probability of E1 multiplied by the probability of E2. Okay, so we've reached the end of this lesson. I don't know if there's any question on what we've discussed under this lesson. Any question? Hello, any question there?
Can you just quickly run through what you were explaining? Like just to run through it.
Okay.
On the multiplication law.
The multiplication law?
Yes.
All right.
And addition.
Sorry?
And the addition law.
Okay. Just a minute. Trying to save something. Okay. So on let's go to the addition law. Okay. So addition law, remember I said that it states that, let's say if you have 2 events, right? You have 2 events. You have event A and event B. Okay. So the probability that any of these, not both, any of them are going to occur, either A or B. The probability that either A or B is going to occur is going to be equal to the sum of the individual probabilities of the 2 events. So in this case, what it means is that you're going to have the sum. So it means that the probability that A or B will occur is going to be equal to the probability of A occurring plus the probability of B occurring. Okay. So it's, of course, it's not so good to master things, but to understand them, it's better to understand. But whenever there is the word or, okay, it means that you're trying to say either this or the other. Okay. But when we say both, it means that you're saying this and that, isn't it so? So whenever you are talking about you are talking about either one of the two events, one of the three events occurring, it means that we are talking about the addition law. Okay. So if you talk about A and B, if you're talking about events A and B, then you want to look at the probability of any of them occurring. Then you have to do what? To add the individual probabilities. So there's the probability of A occurring, and there's also the probability of B occurring. Okay. So the sum rule states that the probability of A or B occurring is equal to the sum of is equal to the probability of A occurring plus the probability of B occurring. So you have to calculate the individual probabilities, then you add them. Is it okay, Msonda? You first calculate.
Yes, it is.
You first calculate the individual probabilities for each of the events, then you add them. Okay. Then you'd have dealt with the sum rule. Then when it comes to addition, when it comes to multiplication rule, you have to calculate the individual probabilities, then you multiply them. Okay. So if you're saying what is the probability of A and B occurring, okay, both of them occurring, in as much as they are occurring independently, but it's like they occur at the same time. What is the probability that they occur at the same time? Okay. Then in that case, you are talking about multiplication rule. And what you do, you have to multiply the individual probabilities. So you have the probability of A and the probability of B. Then you multiply them. You are going to get the probability of A and B occurring. Is it okay, Chisha?
Yes, it's very okay. Thank you.
Okay. I hope we are okay so far. Any other question before we can call it a day for now? I might probably come back again, maybe somewhere around 18:30 or 19 hours, if I tell people will be free. If not today, then we can have another lesson tomorrow. Any question for now? So the best thing that you can do is, if you have past papers, you go to questions that are pertaining what we've discussed now. You go through them and then try to apply what we've just discussed. I think it's going to make much sense like that. Any question on what we've discussed now? Okay, so I think we can probably then end there.